Okay, let's start off with number 1. We would make u equal to x and dv equal to sine of x dx. You take the derivative of u and you get du is equal to dx, and you take the integral of dv, so you get v is equal to cosine x, negative cosine x, and then there's no plus c. So if we plug everything that we have into our equation right here, we would get integral of x sine of x dx is equal to negative x cosine x minus integral negative cosine x dx. We can simplify negative cosine x dx, so then we would get the integral of x sine of x dx is equal to negative x cosine x minus, and then the integral of negative cosine x is negative sine x, so this would actually turn positive sine x, and then don't forget the plus c for your final answer. For number 2, we have the integral of x times e to the x. So u is equal to x and dv is equal to e to the x dx. So you have du is equal to dx and v is equal to e to the x. Plugging everything back in, we have integral of x times e to the x dx is equal to x times e to the x minus integral of e to the x dx. Now, if we simplify this, we get integral of x to the e to the x dx is equal to x times e to the x minus e to the x plus c. So, as you see, for this one, we will try to do Tabular's method. So you would want to do Tabular's method for something like this. First of all, because you have a terminating factor, and second of all, because it would take a lot of time to do this the regular way, since you would have to use this equation 5 times. So when using Tabular's method, you need 3 things. You need plus and minus, you need the derivative, and you need the integral. So you do, for the plus and minus, you just start off with the positive and you keep going. Usually I like doing the derivative so I know when to stop so that I don't have an excess amount of plus and minuses. So if we do the derivative, you start off with x to the 5th, 5x to the 4th, 20x to the 3rd, 60x to the 2nd, 120x, 120, and then 0. So you have a plus, a minus, a plus, a minus, a plus, and then a minus, a plus right here. For the integral, we just have e to the x, and the integral of e to the x is always e to the x. So if we just do that. So for Tabular's method, you don't go sideways, you actually have to go diagonally. So the plus goes with this, and the x to the 5th goes here. Minus here, plus here, minus here, here. So that would leave you with x to the 5th e to the x minus 5x to the 4th e to the x plus 20x to the 3rd e to the x minus 60x to the 2nd e to the x plus 120x e to the x minus 120 e to the x plus c. It is very important to remember the plus c for the final answer. Now, for our last one, it's usually kind of confusing to some people because you would have to make u equal ln of x and then dv equal dx. Take the derivative of u, so du is equal to 1 over x dx, and then the integral of dv, v is equal to x. Now, when you plug everything in, you get integral of ln of x dx is equal to x times ln of x minus the integral of 1 over x times x dx. So 1 over x times x cancel each other's out, and you have a 1. Integral of 1 is x. So integral of ln of x dx is equal to x ln of x minus x plus c. And that is your answer for that one.